First, I will discuss the doubts related to the last week homework, properties of the wave. Mention the question in which you have doubt, so I'll discuss that question. Properties of the wave exercise. Mention the question in which you have doubt. Question 3C. Okay, 3C. Okay, second part. Look, in this question, the wave in B approaches a barrier. The wave in B approaches a barrier that has a larger gap. So when the gap is larger, diffraction will occur, but small amount of diffraction will occur. So the gap is in the barrier is larger than the wavelength. On a figure, draw the pattern of the three crests. So when we draw the three crests, it should be equally spaced, and near the edge, slight curve, which shows a small amount of wave is diffracted. Now, water is added to a tank. So when we add water to a tank, it means it will become deep. And in deep water, the waves will travel faster, speed will increase, as well as the wavelength will also increase. State and explain how the wavelength in a deep water has changed. So what happened to the wavelength? The wavelength will increase. Apart from a change in wavelength, describe one other difference in the pattern. Now, what will be the other difference in the pattern? Because now it's in a deep region. So when it is in a deep region, the wavelength is longer. So as a longer wavelength or wavelength is bigger as compared to the gap. So wavelength is greater as compared to the gap size. Then what we will observe? We'll observe maximum diffraction will occur for the wave. Is it clear? So more diffraction will be there, as we can see that the wavelength because the water is now in a deep region. So deep region, the wavelength is longer. So when it passes through the same gap, it will diffract more. Question 4A3. For A3, state and explain for the sound produced by the loudspeaker how the wavelength of a sound in air compare with the wavelength of a sound in water. So as we discussed, that sound is traveling faster in water or liquid, it is fast as compared to that in gas. Speed of a sound in gas is about 330 or 340 meter per second, so it is slower. So if speed is less, the wavelength will be shorter, and if it's moving faster, speed is greater, the wavelength should be longer, but the ratio between the speed and the wavelength will remain same. So state and explain for the sound produced by loudspeaker how the wavelength of sound in air compared with wavelength of sound in water. So when we compare these two wavelengths, for question number A3, so in air it is shorter, where in water it will be longer wavelength. And for question 8b2, why the wavelength will be different? As we discussed yesterday about the nature of the sound require a medium, and it when it travels from one medium to another, it changes the speed. So in air, the particles are away from each other, and the speed of the sound in air is about 330 meter per second. But in water, the speed of the sound is about 1000, or a liquid 1500 meter per second. Frequency is same when the sound travel from air to water or water to air. The frequency, the number of vibration does not change. So here the speed is smaller, so wavelength will be smaller as well. Ratio will be same, but as it move in a water or passes through a water, speed of the sound wave increases. The wavelength will also increase, but the ratio, which is a frequency between speed and wavelength, will remain unchanged. So if speed increase, the wavelength should increase. If speed decrease, the wavelength should decrease. But the ratio between them will remain unchanged. Next is question number 8. Before 8b, it's 7b. So in question 7, wave passes through a gap in a barrier. The wavelength of a wave has the same magnitude as the width of a gap. Tick the box, indicate what happened to the wave. So diffraction will now figure 5.1 shows 6 wave fronts traveling from a deep water to shallow. On a figure, draw the wave front, because in a shallow water the wave will travel slower, so the wave front will lag behind. So using a ruler, a scale, you can just make these parallel lines. The wavelength should appear that it is decreased. Speed also decreased, but the frequency remain unchanged. In 7, this was 7b. Then next part, the depth of a shallow water is now changed so that the speed of the wave in a shallow is 0.6. The speed of the wave in a deep is 0.8. And the distance between the two successive wavefronts is 1.4. Calculate the wavelength. So how to calculate the wavelength? As we know, the frequency in a deep water and frequency in a shallow water is same. Frequency does not change. And frequency is speed divided by wavelength. So we can say speed in a deep region divided by wavelength in a deep region is equals to speed in the shallow region divided by wavelength in a shallow region. So speed in a deep region, as you can see, the depth of a shallow water is now changed so that the speed of the wave in a shallow is 0.6. So in a shallow, it's 0.6. The speed of the wave in a deep is 0.8. That's 0.8. The wavelength of the distance between the two successive wavefront in a deep region is 1.4. So this value is 1.4. Then wavelength in a shallow region will be x. Cross multiply. So lambda is equals to 1.4 multiplied by 0.6 divided by 0.8. You will get the wavelength, but that will be in centimeter because I took a ratio. So I will get answer in centimeter and I can convert that into meters. The meaning of a dispersion. Dispersion means this topic we will discuss. Dispersion means when a white light, which is a combination of 7 color, violet, indigo, blue, green, yellow, orange and red, when it passes from one medium to another, it is spread into 7 component. This is known as dispersion. Dispersion is when the white light, is spread into its component. We call that as dispersion. And for a narrow gap, why for a narrow gap the amplitude decreases? Because it's like, for example, a wave is transferring 100 joules of energy. If it is transferring 100 joule of energy, and if maximum diffraction occur, so what happened? The intensity or the amplitude of the wave decreases, because all of that 100 joule is spread. So each will receive, like example, this is 20, 20, 20, 20, and 20. So what happened? You can see all the 100 joule of energy, as it passes through a gap, it's spread out, or maximum diffraction occur. So whenever the maximum diffraction occurs, the amplitude or the intensity of the wave decreases. But if small diffraction occur, the amplitude of the wave, small change in amplitude, because small diffraction means that small part of the wave is changes the direction. So most of the energy is transfer or travel from one place to another. So if less diffraction, maximum amplitude; more diffraction, smaller amplitude. Then question number 8. Question number 8, B1. State the effect of increasing the width of a gap in the barrier, and state and explain the effect of increasing a frequency. So if we increase the gap, so it will reduce the diffraction, because if we increase the gap, a small amount of diffraction will occur or less diffraction will occur. The state and explain effect of decrease. No, actually, it's not like the frequency changes due to diffraction. What they mean to say, like we are using another wave which is having a lower frequency, means this wave was used, now they're using another wave which is having a lower frequency, or lower frequency means higher wavelength. Because of diffraction, the frequency will not change. But what they mean in the question, that they're using another wave which is having a higher wavelength or a shorter frequency. So shorter frequency or longer wavelength. So you can see the gap size is smaller compared to the wavelength. So what we will observe? We will observe the diffraction pattern will be more, or diffraction will increase. Is it clear? And question 9A. Straight wavefront produces on the tank and travel towards the gap. The curved wavefront travel away. Name the process. In the second part, suggests a cause of reduced spacing. Like reduced spacing means why the wavelength before the gap, passing through a gap, and after it passes through the gap, why the wavelength is decreasing. So what it gives an idea, maybe the region changes, that the water might enter from deep to shallow. That's why the wavelength is decreasing. Is it clear? Any other doubt in this exercise? Properties of the waves? For question 10, the lines should be equal length, like equal size. When I'm drawing, it's moving from deep to shallow, so it's not it's acceptable. You can draw till the edge, or you can draw in this manner. Both ways it is acceptable. Any other doubt in this exercise? So I'll start the topic.